Hello and welcome back. In this video, I'm going to take you through the process for uploading a CSV flat file into Zoom Data and setting it up as a data source. Let's get started. So I'm going to jump into Zoom Data now. I'm going to log in under this account here. Now, to start off, we're going to have to add a data source. So the way we do that is we click this gear icon and go to Sources. You can also access your data sources through the hamburger menu by clicking it and hitting the Data Sources tab and hitting Edit Data Sources. That'll take you to this exact page. Now, what we want to upload is a CSV flat file. So I'm going to click the Flat File button here, and that'll bring me into the page where I can create that source. Now, we're going to use some FAA flight delays data. So we're going to name this source FAA Flight Delays CSV. We don't need a description for now, so let's hit Next. This page here will let us upload the necessary files. Now, the file will be provided for you. I have it here. It's going to be FAA Flight Small. This is a restricted set of the FAA's list of flights and related flight delays from the year 2015. It's restricted to 5 key airports. We're also going to connect to an Impala data source that has some larger data, has the complete data set with 5.8 million records in another video. Now, as this uploads, I'm going to take you through some information about Zoom Data's flat file upload. We accept CSV, TSV, XML, and JSON files up to 500 megabytes. If you want to do more than 500 megabytes, we recommend you put it on an external storage like S3 or a distributed file system like HDFS, or upload it to a data source like Hadoop or Mongo. Now, you see that it's finished uploading and this data preview has shown up. So we're going to go through this data preview and see if all our attributes are here, which they are, and if everything looks right, which it does as far as I can tell. If you want to preview more rows, you can change this here, and now more rows will become visible. If this is a tab-separated file that Zoom Data accidentally detected as a comma-separated file, you can change the separator here to a tab, depending on what's your separator, or a semicolon. And if you hit Apply, Zoom Data will parse it again with the new separator. Now, it auto-detected a comma-separated file, and that is fine for our purposes, so we're going to leave that be. Down in the bottom left, you're going to see this caching toggle here. So Zoom Data has inbuilt caching, and it will store metadata, ranges, and result sets for all the different visualizations you make. Caching is generally very useful because if you create a dashboard on some data, it'll cache some information so the next time you load that dashboard, it will load more quickly. And so I would only recommend turning caching off when it's causing a problem. And caching has not caused a problem for me in any of the data sources I've worked with. So I would always leave it on. Now, for convenience purposes, we have this attribute type selector. And for each field, you can select a type here. Now, you'll see when we go into field management, which is the next section of this process, you'll also be able to change type there too. These are two ways to access the same functionality. The reason it's provided here in the file path is because the field type is auto-detected from the data Zoom Data sees in the CSV file we uploaded, and that might not completely be right, and this is an easy way to validate that data when you're uploading a CSV. For example, flight number was auto-detected as an integer. We actually want that to be an attribute because flight number, while it is an integer number, we're never going to do math on the flight number. We won't want to find the sum of all the different flight numbers. Instead, we might want to group by different flight numbers, perhaps in like a scatter plot, or maybe we're going to group them by their airline. So we can change it that way. Moving on, we have field management. So this table shows you all those different fields you saw in the columns before as rows. and it lets you change different functionality about those fields. And I'm just going to go from left to right and tell you what each of these columns means and does. So on the left here, this checkbox toggles visible. So if you've connected to a data source, but there are certain fields that aren't really necessary right now, and you don't want people using your visualization to be able to see them, you can uncheck visible. So for example, we have departure delay, but it's also broken down into air system delay, airline delay, as well as weather delay. Now, we might not want to have these sub delays because we already have the total delay. So we can uncheck them and they won't show up later on when we're visualizing this data. That can be useful sometimes. Now, I'm going to recheck them because it's not really that big of a deal right now. There aren't any reasons why they shouldn't be part of the list, but now you know what that functionality does. Next up, we have field ID. You can't edit this. It just shows what Zoom data has pulled in as the name of the field in the underlying data. For example, wheels_off is the name of one of the fields that actually shows the time that the aircraft's wheels left the ground when it was taking off. Now, what you can change is the label. So for example, if one of these labels is not human friendly, if it's not something you want showing up in the axes of your charts, you can change it to something that is a little more easy to deal with or a little more understandable for the users who are going to be using your data source. We're actually going to do that here. Down here, we have the volume metric, and that's automatically created based on how many rows of the table get grouped into a certain group when you visualize. So what that means in our context is this is flight data. Each row in this table is a flight. And so when we select a group or when we filter it and it detects 400 rows, that's 400 flights. So instead of the really abstract generic term volume, let's use the more specific number of flights so that now people know exactly what we're looking at when we say volume. Next up is the type. So we just saw that same type picker in the previous page. This lets you also change the type here. And this is really the main place where you change types in all data sources because only really flat file upload has that other convenience feature. I'm going to take you through the types real quick. The most important ones are attribute, which represents essentially a dimension or a category within which there are items. For example, if you have airline, that's an attribute because you have like a category, airline, within which there are different items. For example, American Airlines or United Airlines. So if you want to create a bar chart comparing all the different airlines, your attribute is going to be airline. So a nice way to think about it is if you're making a bar chart comparing different things, those things that you're comparing are going to be the items inside the attribute. Anything you're going to want to group by is going to be an attribute. We also have integers and numbers and money. These are all metric types. So this is essentially things that can drive things like the height of bars or the direction of a line in a trend graph. Integer doesn't have decimal places. Number does have decimal places. And money has some additional features that are helpful for dealing with money data. Now, in our case, we only use integers in this data set because airline delay is in minutes and we don't have hundredths of minutes or tenths of minutes in this data set. Everything's in integers. The other type of data type we have is time. Time is treated a little differently. You can use time to filter data for different time ranges, and you can also use time to group data. For example, if you want to compare each month's average airline elapsed time in the air, you can do that by grouping by time and then selecting compare by month. And we're going to go into that later on when we look at data visualization. Moving on, for each type, there are configuration options. For example, arrival delay, which is the number of minutes that a plane arriving at an airport was delayed, has the option for configuring the default aggregation. So when you have a type like an integer, which is a metric type, ZoomData will automatically calculate aggregations based on it. Sums, average, max, and min. Some will add all of the things you've got up. So for example, if you want to know the total amount that all planes in January 7th were delayed, that would be the sum. The average takes the average of all the data you're selecting. Max takes the highest point, min takes the lowest point. You can configure this later for individual visualizations, but here you can set the default. And what we're going to do is set the default for arrival delay and departure delay to average, because when we're looking at these, most of the time, we're going to want to know what the average delay was. We're not going to want to know, the total number of minutes that all these planes were delayed was this many minutes. Another thing to note is time has different settings as well. You can configure time patterns for time. In our case, we're using ISO time format, so that's not going to be a big deal for us. But dates and date times can be formatted in different ways. But since we're already in the default, we're fine. We're also using minute granularity, but if you have less granular time, you can set that up here, as well as time zone. Now, time zones can get difficult to deal with, so one personal tip I would give you is keep everything in UTC, or just keep everything in the same time zone and have that be the same time zone the ZoomData instance is running in. That way you don't have to deal with confusing daylight savings time, leap year, leap minute, leap second issues, which honestly can cause a lot of very confusing headaches. So none of that's going to affect you if you keep everything in the same time zone. Next up is this distinct count checkbox. Distinct count can be useful for different types of aggregations. Essentially, what this is good for is, let's say you have an attribute like airline, right? Now, let's say with your chart, you're charting 400 flights. And of those 400 flights, you want to know how many airlines were there that carried these flights. If you check distinct count, airline will now have a metric associated with it called airline count. And if you click that, it'll say, for example, 5. And what that would mean is of these 400 flights, only 5 airlines served them all, because it groups up if there were like 50 United flights and 150 American Airlines flights and then 200 Spirit flights, and that built up to 400, that would still group down to 3 because it's 3 different unique distinct airlines. Hopefully that kind of helps you guys understand what distinct count does. Now, we're not going to need it, so we don't have to check it here. Filter display gives us some additional information and additional controls to limit the amount of information that's displayed. For example, for an integer, if you click custom range, ZoomData will actually do some basic sampling to try and figure out what like the highest and lowest values in the dataset are and set that to the custom range. However, if you want to set a more restrictive range, you can. And this can be useful for when you have data, but you only want to look at data maybe between 0 and 15 minutes. Or maybe you don't want to look at data with a delay that's less than 5 minutes because you only want to look at the delayed data. You can use custom range to set that up. Another more specific feature is this only allow custom values checkbox for attributes. And what this lets you do is, one thing you'll be able to do in ZoomData's visualization is filter on an attribute. For example, when you hit flight number, there's a button you can click that shows you all the different flight numbers, and you can say, only show me 2548. Now, that can be useful, but if we're working in an environment where there are security concerns, where we don't want people knowing all the different flight numbers, and we only want them to be able to access a flight number if they can type it in beforehand, if you click this, it won't show that list anymore, and you have to type it in yourself to be able to filter on it. So that can be useful in specific niche situations where there are security concerns. Moving on, this last column here is the info column. Right now it's not going to show us anything, but if your underlying data source has, for example, descriptions for the different fields or information that will flow in that's just information about how this field is set up that will show up in the info panel. So that's field management. One thing to note is we automatically create a volume metric, and here you can also create calculated fields. And if you do that, you can actually generate fields that are calculated based on other fields. In another video, we're going to look at how to create calculated metrics, and that process is going to be pretty much the same as this one. So if you're especially interested in creating calculated fields and metrics, you might want to take a look at the configuring visualizations video in this course. But moving on, if you click this button, it will save this information, so it's going to take a little bit, and move us to chart-specific settings, where we can enable and disable individual charts and change some global defaults. All right, so now we've moved on to chart-specific settings. And one thing to note is that your source isn't saved yet. You're not going to be able to use it until you hit finish. So sometimes what can be useful is to just hit finish, preview the chart, and then go back and change your chart-specific settings based on what you see in the preview, which is what we're going to do now. But before we do that, there are a few things I do want to change before finishing this up. In global default settings, I want to change arrival time to scheduled departure because this is the main time field for this data set. And I'm going to click Enable Playback, and that'll let us play back historical data in real time. Finally, in default time range, I'm going to change it, since this is for the year 2015, to January 1st at 12 a.m. and have it end at December 31st, 2015. So we covered the year 2015. Another way to do this is to use time presets and click max available range. And since what we're doing is essentially identical to the max available range, it should set up that data identically. Down here are settings for individual charts, but as I said, let's hit finish, validate it, and see what we can change with those chart settings. Great. So our source has been saved, and now we have this handy shortcut we can use to build a chart around it. So let's start with a bar chart and see if everything worked fine. Letting it load, we should be able to see some bars. And that's perfect. Great. So these bars don't make that much sense, but it looks like all our different groups and all our different metrics loaded in fine. Now, what we're looking at right now is a chart of number of flights grouped by cancellation reason. Now, this big bar here is null because the vast majority of these flights weren't canceled. If we get rid of this bar, we can see that most flights in 2015, you can see the time range down here, were canceled because of weather, followed by airline carrier and national air system. Now, I'm going to move this to something that I think is a more helpful group by. Let's group by origin airport so we can see how many flights came out of each airport. So O'Hare, Dallas-Fort Worth, LAX, Atlanta, and International Airport Dulles. Cool. So that's kind of interesting. One other thing that you might want to watch out for, especially in data sources like this, which have multiple time fields, is the trend attribute. So if I change this chart style to a line chart, fantastic. This is a monthly line chart. You'll see that the trend attribute here isn't the same as the attribute in the time bar. And what this means is essentially that you're choosing between January 1st and January 31st, 2015 in terms of scheduled departure, but you're trending on arrival time. And while these are, in this data set, these are pretty close times to each other because flights arrive and depart at about the same time, this can be very confusing if you're dealing with other forms of data. For example, you might be working in parcel delivery, and you can say you might have two time fields, one for order made and one for order delivered. and order delivered might be 2 or 3 weeks after order made. And if this time bar were on order made and this was on order delivered, you would be looking at orders that were made between January 1st, 2015 and December 31st, 2015, but you'd be trending the orders that were delivered during that time. So what that means is that in that particular situation, you'd get some weirdness near the start of the year because you're looking at orders that were made in the start of the year, but there would also be orders that were delivered that are being displayed. So so if these were consistent, there shouldn't be any orders in the beginning of the year. But the point is just you want to be aware that there's a difference between a trend attribute and the attribute in your time bar. And if you want the time bar and the trend attribute to control the same thing, you need to set them to the same thing. So in this case, we can set it to scheduled departure. And you can see that gets rid of, when we had arrival time, this drop here in January 2016. And the reason why that's happening is because we're looking at flights that departed in 2015. But since our trend attribute's 2016, there are flights that departed on December 21st, 2015 that landed and arrived in 2016. So we get this weird point here with just 12 flights compared to the thousands of flights that are here. If we set this consistently, it's scheduled departure, you'll see that point disappears. So that's just something to keep in mind when you're working with the time bar and trend attributes. So let's go back to our sources and use this information we've learned to change our source chart specific settings. So the name of our source was FAA Flight Delays CSV. And if I click this, we'll be back in this familiar setup screen. We're going to go to charts, and these buttons up top let you navigate. We're going to go to charts. And so let's make some of those changes that we saw. So in bars, we want the default to be origin airport because it's more useful. Now you could set it, each time you create a chart, you could set it manually to origin airport, but if we set it as the default, we won't have to do that over and over again. So that can be helpful. And then for these line trend charts, we're going to want to set the trend attribute to scheduled departure by default. And that's going to be scheduled departure. Fantastic. All right. One other thing to note is if you've got custom visualizations, they will show up in this custom tab. We don't right now, but if your organization makes custom visualizations, that tab can be really useful to set them up and also to enable them and disable them, especially if the visualization was made to be used with a specific data source, but not other ones. Fantastic. Now that we're done, let's save again. Let's create a new chart and dashboard, make sure that everything's working as it should. So now the default should be origin airport, which it is. And you can see that IAD still trails in the back. Fantastic. So now we've gone over the entire process of how to connect to a CSV file in Zoom Data. In the next video, I will outline the exact same process except for connecting to an Impala database. Thanks. See you in the next one. Bye-bye.